Hi everyone, my name is Christy Sun and I'm the VP of Growth Strategy at HYPERION Optics. First of all, I'd like to thank the entire EPIC team for putting together this incredible virtual platform for all of us to connect. Today, I'm happy to present to you a few case studies to illustrate HYPERION's engineering capabilities beyond optics fabrication and how that might make a positive impact in your product development cycle. So before I dive into the case studies, I'd like to give a quick overview about our company and what we do. So HYPERION Optics is a one-stop shop photonics supplier and engineering house for high precision optics and lens assemblies. So we specialize in complex, high resolution, diffraction limited optical assemblies from prototype to production. We offer several unique advantages to help clients from launching a new product to optimizing an existing system. Our key differentiator is really our integrated expertise in optics fabrication and optical engineering. So our clients leverage our engineering services to verify proof of concepts, to build scalable solutions, and to meet high precision specialized use cases where next level engineering support might be required. Now, we offer engineering services including design for manufacturability and assembly input, which is critical in terms of ramping up a production from a smaller initial low quantity type of product build. So this includes tolerance, optimization, and redistribution, which even a small tweak or adjustment might make a huge impact down the line in volume production. So we help clients to avoid these sort of early stage design pitfalls that might be costly down the road. We also offer rapid prototyping services, which include feasibility study for proof of concept type projects, optimal material suggestion, and cost and yield analysis. We offer design optimization, of course. So if you have an existing design that you'd like to optimize in terms of cost or performance, HYPERION can help. And also application-specific optical and optomechanical engineering support, which is a big part of of the case studies that I'll cover next. So for this first case study, we helped a biomedical company develop a complete OCT imaging system last year. So OCT, or optical coherence tomography, is an imaging technology that has become broadly adopted in the medical imaging and also industrial non-destructive testing applications. So nowadays, doctors and scientists are leveraging OCT technology to study the retina of COVID-19 patients against health control groups. So our job here is to deliver an optimized second generation design for their existing product based on their first generation design. Now the kick is we did not have access to their first generation design due to IP restrictions. So our challenge was to quickly identify areas for optimization and potential optomechanical interferences in the early phases. Now, the second challenge this client threw at us is that we had to deliver the complete prototype in under 8 weeks, which was a very aggressive schedule. In the end, we were able to achieve and meet their schedule and actually completed all customized complex part focal and part center test requirements, which correspond to 4 different groups of light paths. So it was quite impressive given that it all happened during the pandemic. So this is the optical schematic of the OCT system that we developed. And as you can see, is a complex system that involves over 20 plus optical elements, including spherical and aspherical lenses, dichroic filters, and reflectors, and also roughly about 40 optomechanical parts. So we're able to help companies with a quick, with fire rapid prototyping for system level assemblies such as this one. Now on to our second case study, which is a scientific project that we have done for Lawrence Berkeley National Lab. So the goal here was to design the next stage space telescope to capture signals from the Big Bang in the cosmic microwave background. So when the chief scientist approached us, he had a pretty ambitious design that incorporates very robust silicon dome lenses with a special glass dome coating on top, as you can see on here on the left. The dome coating is required because this application extends over into microwave wavelengths. Standard air coating is not sufficient. So the HYPERION team conducted studies on selected material and the material indexes with the anticipation of the index shift in their working environment. And ultimately, we're able to narrow down to a few compatible materials that would serve as this glass coating. Now, keep in mind, this entire lens array would need to withstand temperature down to negative 273 degrees Celsius during the launch into space. So our study also include consideration to ensure that the CTE compatibility between the silicon and the coating material, as well as the cement material itself, would be able to withstand the level of thermal expansion that this application would require. So this is what the finished, the rendering of what the lens array would look like on top of the detector module. And I hope these two case studies are able to illustrate how HYPERION's team can leverage creative engineering to bring unique scientific designs to life. And as closing remarks, I'd like to encourage all of you to reach out to us and let us know about your unique application challenges and design challenges, and see how we can add value in your R&D efforts. So we work with clients all across the industry, such as LiDAR application. Trying to play this video here. Oh, okay. Such as LiDAR applications, night vision or thermal imaging, or even commercial application like heads-up display. So let us know what your unique applications are and what your unique application needs are. We'll be happy to help and see how we can help you prototype and add value to your R&D efforts. So please feel free to reach out, and in the meantime, stay well, take care. I look forward to meeting some of you next year, hopefully in an in-person event. Thank you again so much for your valuable time.